Hello everyone. Welcome back to our FPS Beginner to Advanced Controller series. And in today's episode, we're going to continue improving our FPS weapon system even further. We'll add weapons idle, breathing sway, and movement sway, but first we'll fix an important issue. And this is a super common FPS problem called weapon clipping. Now let me show you the issue. If I move close to a wall, you can see our weapon starts going inside the wall geometry. And obviously this completely breaks the immersion. This happens because our weapon is being rendered by the same camera that renders the environment. So whenever the camera gets too close to a surface, the weapon clips through the wall. And this is a very common issue in FPS games. So now let's properly fix this problem using a separate weapon camera setup. Let's select our player from hierarchy, and inside our player, select the main camera. Right-click and create a new camera and rename this to weapon cam. And make sure the position of the second camera needs to be the same as of main camera. Since this weapon camera is only responsible for rendering the weapon, we don't need a huge rendering distance for it. Set far to 20 and near to 0.1, because if the near clipping value is too high, parts of the weapon can start disappearing or getting cut off when they come close to the camera. Next, we need a separate layer for our weapon objects. Select our weapon from hierarchy, and let's add a new layer and name this as weapon. Now select weapon again and assign this weapon layer. Select yes, change children, so this weapon camera can render every child a weapon. Now we need to configure our cameras correctly. First, select the weapon camera. Inside the culling mask, I'll disable everything and only enable weapon. So now this camera will render only weapon objects. Next, select the main camera, and from its culling mask, I'll remove the weapon layer. So now the main camera renders the environment, enemies, and world objects, but not the weapon. Now there's one last thing we need to do. Select weapon camera, and inside the camera settings, change clear flags from skybox to depth only. Now let's understand why we're doing this. Right now, if both cameras render the skybox and background, they'll start overlapping each other. But we don't want the weapon camera to render the whole environment again. We only want it to render the weapon on top of the main camera output. Now let's test the game again and move close to walls. You can see the weapon no longer disappears inside the geometry like before. And this instantly gives our FPS system a much more professional feel. Now let's add our next feature, which is idle weapon sway. We already have a weapon sway serializable class. So instead of creating a new script, we'll extend the same class. Right now, our weapon sway only reacts when we move the mouse, but when the player is standing still, the weapon becomes almost static. So to make it feel more natural, we'll add a small breathing movement. First, inside our weapon sway class, we'll add a new header to organize our inspector and name this as idle weapon sway settings. Now we need a value for breathing strength. Let's add private float breathing amplitude and set it as value to 0.02. This controls how much the weapon moves during idle breathing. A small value is better here because we only want a subtle motion, not a huge movement. Next, we need breathing frequency. Let's add a new private float breathing frequency and set its value to 1.5. This controls the speed of the breathing motion. Lower value means slower and calmer weapon movement. Next, we need a transition speed. Let's add private float transition speed and set it as value to 2. This controls how smoothly the breathing sway starts and stops. We don't want the idle sway to suddenly appear or disappear. So this value will help us blend it smoothly. Now we need a breathing weight. Let's add private float breathing weight. This value controls how much idle breathing is currently active. When the player is idle, this value increases smoothly. And when the player moves or rotates the camera, it goes back to 0 smoothly. Now inside our gun sway method, first of all, we'll check if the player is idle. Let's add a local bool is idle. And we'll check 4 inputs here. We'll check if input dot get axis horizontal equals 0. And if input dot get axis vertical equals 0 as well. And also if input dot get axis mouse x equals 0 as well. And last, we'll check if input dot get axis mouse y equals 0 as well. So if all these values are 0, that means the player is not moving and not rotating the camera. That is our idle state. Now we'll smoothly update the breathing weight. Let's say breathing weight equals mathf dot lerp. And from breathing weight and check if the player is idle, we move breathing weight toward 0.2. If the player is not idle, we move it back towards 0. And then for smooth transition, time dot delta, time, multiply with transition speed. Now we are smoothly updating the breathing weight. Next, we need to calculate horizontal breathing offset. Let's add a local float, offset x equals. Here we'll use mathf dot cos to create a smooth side-to-side motion. Cos gives us a smooth wave value going between -1 and +1. Time dot time, the time since the game started, because this value keeps increasing every frame. It allows our breathing movement to keep animating over time. Multiply with breathing frequency. This controls how fast the breathing animation moves. Then we multiply frequency by 0.5. This makes the horizontal movement slower. After that, outside the cos function, we multiply by breathing amplitude. This controls the strength or size of the breathing movement. Then we multiply by another 0.5. This reduces the horizontal movement amount. Finally, we multiply by breathing weight. This controls how active the idle breathing effect is. Now we calculate vertical breathing offset. Let's add a local float, offset y. And here we'll use mathf.sine. Just like cos, mathf.sine also creates a smooth wave value between -1 and +1. And this is perfect for creating natural animation movement. Time multiplied by breathing frequency. This keeps the breathing animation moving every frame automatically with control breathing animation up and down. Now outside the sin function, we'll multiply by breathing amplitude to control how strong the vertical breathing movement is. And finally, we'll multiply by breathing weight to determine whether the breathing effect should actually be active. Next, we need to store both offsets into one vector 3. Let's say vector 3, idle breathing vector equals new vector 3. And for x, offset x, and for y, offset y, and z will be 0. This vector stores the final idle sway movement that we'll add to the weapon position. Here at where we are setting weapon local position, we'll just add this vector. So now the weapon position is controlled by 3 things. Mouse sway position, original weapon position, an idle breathing movement, save script, and back to editor. Now you can see we have idle weapon sway variables in weapon controller script as well. Now let's test the idle weapon sway system. And if I stand still for a moment, you can see the gun is now smoothly moving with a subtle breathing motion. It's a very small detail, but it makes a huge difference in how realistic and polished the FPS weapon feels. Now, the weapon no longer feels completely static when the player is idle. Now, our idle weapon sway system is working nicely. But there's still one thing missing. If I start walking, you can see the weapon becomes completely static again while moving. And obviously, in real FPS games, weapons slightly bounce and move while the player walks or sprints. So now let's create a proper movement sway system. And just like idle sway, we'll use the same weapon sway class for this as well, because all these systems are related to weapon position movement. Open up our weapon sway system. First, we need movement amplitude values to control left, right, and up and down movement. First, let's add a private float, move amplitude x, and equals 0.05. This will control left and right movement. Just duplicate this for y amplitude and set its value to 0.03, and this will control up and down movement. Next, we need movement frequency. Let's add private float movement frequency. and set its value to 7. This controls how fast the weapon sway animation plays while moving. And finally, we need movement weight. Let's add private float movement weight and set its value to 0. This value controls how active the movement sway currently is. When the player starts moving, this value smoothly increases. And when the player stops, it smoothly returns back to 0. This prevents sudden movement snapping. Now we'll extend our gun sway method. Inside our gun sway method first, we'll check whether the player is moving. Let's add a local bool is moving equals input dot get axis horizontal not equals 0, or input dot get axis vertical not equals 0. Here we check if either horizontal or vertical movement input exists. If any movement key is pressed, then the player is moving. Next, we'll smoothly update movement weight. Let's say movement weight equals mathf dot lerp from movement weight, and check if player is moving, movement weight will be 1. Else 0, again, for smooth blending time dot delta time, multiply by 5. Now we also want different sway speed while sprinting. Let's add local bool is sprinting equals. And now instead of writing the sprint system again here, we have sprint system in our FPS controller and we can utilize it. First of all, let's pass the FPS controller reference in this gun sway method. Let's add second parameter FPS controller, FPS, and assign FPS controller bool is sprinting to it. But wait, we can't access it here because it's a private variable. We need to change it from private to public to access it. And now we can access it and assign it to local bool. Now, depending on sprinting, we'll change movement frequency. Let's say our movement frequency equals, if the player is sprinting, movement frequency will be 10L7. This will instantly make sprinting feel more energetic and dynamic. Now let's calculate horizontal movement sway using cos function like we did before for idle sway. Let's add a local float, move x equals mathf.cos. Inside this method, to keep the animation running continuously, we'll say time, dot time, and multiply it with move frequency. And we'll multiply this cos function with move amplitude x to control sway strength, and multiply with movement weight to control whether movement sway is active or not. Next, we calculate vertical movement sway. Let's add a local float, move y equals mathf dot sign, and here we'll pass time dot time and multiply it with move frequency and multiply it with 2 to make vertical movement happen faster than horizontal movement, and multiply this sine function with move amplitude, y to control sway strength, and multiply it with movement weight. Next, we need to store these both movement value in vector 3 to add it to the weapon position. Let's add vector 3, movement sway equals new vector 3, and for x value it's move x, and for y it's move y. The z is 0. Now let's add this movement sway into our weapon position. Back to our weapon controller. As you know, we are passing 2 parameters in gun sway method. So we need an FPS controller variable in weapon controller script. Let's add private FPS controller, FPS, and assign its reference in the start method by getting component from parent, because weapon is a child of our main player, and FPS controller script is attached on main player. And finally, pass this FPS in our gun sway method as second parameter. Save script, hit play, and test the movement sway. Let's move the mouse. Our mouse sway is working, and let's stay idle for a second. Our idle sway is working perfectly. And now let's move our player, and you can see we have a nice movement sway. And let's sprint to check movement sway while sprinting. And we have a nice smooth transition of weapon movement while walking and sprinting. Now, if I test the game while moving and shooting at the same time, you can see we currently have a problem. Our weapon sway and recoil systems are both trying to control the weapon movement simultaneously. And because of that, both systems start interfering with each other and create unnatural weapon motion like this. Let's quickly fix this. So to avoid this issue, we'll temporarily stop weapon sway while shooting. Now inside our gun sway method, we'll add another parameter. Bool is shooting. Now at the very start of the method, we'll simply check if is shooting, then return. And we'll immediately stop executing the sway logic. Now we need to send this shooting state from our weapon controller script. And here, let's create a new private bool is shooting. This variable stores whether the player is currently firing or not. Now inside update, we'll assign this input into this variable. Let's say is shooting equals this input and add the boolean shooting condition. And finally, pass this is shooting bool as third parameter of our gun sway method. Save script and test the controller again. Now let's move and shoot at the same time. And now you can see the weapon behavior is much cleaner. While shooting, we only have the recoil effect active, so the gun kickback feels more stable and more realistic compared to before. So that's it for this episode. In the next episode, we'll add an aiming system, and we'll also add player head bob effects while moving.